Hey guys, this is Mrs. Lyons, and we are taking a look at the homework on single replacement reactions. All right, so I'm just going to work through these 10 equations kind of quickly for you in case you need a little bit more help in predicting the products. Okay, so remember we said in a single replacement reaction, we have to either compare the two metals or the two nonmetals. Okay. So what you've got to do is you look at the element. So in this case, zinc is the element, and that's a metal. So you're going to compare zinc to the other metal. So in this case, we're going to compare zinc and silver. All right, we're going to look at our activity series. Remember, the higher up the element is on the list. Remember, we joked in class and we said the more Rs that element has, meaning the more reactive it is, the more likely that element is going to end up as part of a compound versus being alone. Okay, so if we're comparing zinc and silver, let's see, where's zinc? Here's zinc. And silver's all the way down here at the bottom. All right. So zinc is higher up. So what's going to happen is zinc is going to take silver's place. So we are going to end up with zinc nitrate. Okay. Plus silver ends up by itself. Okay. So now that we have our equation, the reaction actually takes place. Okay, what we need to do is we need to take this from a word equation and turn it into a chemical equation. So zinc is just going to be Zn when it's just the element. We haven't got any subscripts because it's not one of our 7 diatomics. So zinc is going to be a solid. All right, it's going to react with silver nitrate. Okay, silver, if you remember, we said silver always has a +1 charge. Nitrate is on the back of your periodic table, so NO3 with a -1 charge. So we're going to have zinc plus AgNO3. In single replacement reactions, whenever we have a compound, it's going to be aqueous. It's dissolved in water. Okay. And then those two things combine, okay, the zinc and the silver switch places, and we end up with zinc nitrate. Zinc always has a +2 charge. Nitrate, still NO3 with a -1. Okay, so we end up with zinc nitrate, so ZnNO3 2. Okay, it's a compound, so that's going to be aqueous. And silver ends up by itself, and it's going to be solid silver. All right. Now, if you look at this reaction, okay, if you notice here, this subscript of 2 tells me I have 2 NO3s. Over here, and I'm going to put parentheses around my NO3, I only have 1. Okay. So if I put a 2 out front here in front of silver nitrate, now I have 2 NO3s. I also have 2 silver. So I put a 2 there, and my equation is balanced. Okay. All right. Equation number 2, sodium plus aluminum sulfate. So I'm going to compare sodium and aluminum. So I get out my activity series. Aluminum is right here. Sodium is up here. So sodium is more reactive. Sodium is going to end up in the compound. All right. So sodium is going to take aluminum's place. All right. So we're going to end up with sodium sulfate. All right. Plus aluminum. Aluminum ends up aluminum by itself. All right. Now, since the reaction takes place, we have to write a chemical equation. So we start out with sodium, which is Na. That's a metal, so it's a solid. plus aluminum sulfate. Okay, aluminum has a +3 charge, and sulfate, I'm just going to write this over here. Actually, if you look on your sheet, sulfate is right here, SO4. Oops, you can't see it. There we go. Sulfate is SO4 with a -2 charge. So I'm just going to over here up in this corner show you. So aluminum has a +3 charge. Sulfate is SO4 with a -2. Okay. So this 3 comes down outside of the parentheses. This 2 comes down. So our compound, aluminum sulfate, ends up being Al2SO4 3. That's a compound, so it's aqueous. All right. Now, our products are sodium sulfate. Sodium is +1, sulfate. So I'm going to write this. Sodium's +1, sulfate's -2. So I end up with Na2SO4 aqueous plus aluminum by itself, so aluminum metal is a solid. All right. Number 3, aluminum and lead nitrate. So again, we're going to compare aluminum and lead. So let's see, here's aluminum. And lead is all the way down here. So aluminum is higher. Aluminum, and I showed you in class, I put an asterisk, and I hadn't been doing that. I just kind of, it helps me know if I put a little star by the more reactive element, I know that that's the one that needs to be in the compound. Okay. So in this case, aluminum replaces lead. So we end up with aluminum nitrate plus lead. Didn't leave us enough room to write on this. And I did not include this. I told most of you in class, this should have had a Roman numeral 3, so lead 3 nitrate. All right, so let's write our equation. So aluminum, all right, is just Al. Oops. Get that cursor out of there. All right, aluminum is just Al. It's an element, so it's a solid, plus lead nitrate. So this Roman numeral 3 tells us lead has a +3 charge. Nitrate is NO3 with a -1. So we end up with Pb NO3 3. Okay, that's aqueous. And that produces aluminum nitrate. Aluminum has a +3 charge. So aluminum, that's going to be Al NO3 3 aqueous plus lead Pb. All right, and this one is already balanced, which is sweet, and we don't have to balance it. Okay, so reaction number 4, we have lead plus zinc nitrate. So we're going to compare lead and zinc. Zinc is higher, so zinc is the one that gets the star. Zinc is the one that wants to be in the compound most. It already is in the compound, so this is a NR, no reaction. Okay, so we don't have to do anything else with that one. It's just done. All right, now this one's a little different. If you look, chlorine is in this little list at the bottom. There's only 4 elements here, okay? And in this reaction, we have chlorine and barium iodide. So we're comparing chlorine and iodine. So chlorine is higher up, okay? So chlorine is going to be the element that ends up in the compound. So it's going to take iodide's place. So I'm going to end up with barium chloride plus iodine. Okay. So writing our equation, barium has a +2 charge, iodine has a -1. So I end up with BaI2. It's aqueous. Plus chlorine. Now chlorine is one of our 7. It's a part of Oberfinkel. So it ends up being Cl2. It's one of the diatomic elements. And it's a gas. Okay. So then what we end up with is barium chloride, which is going to be BaCl2, aqueous, plus iodine, which is another one of the Oberfinkel 7. All right. It's a diatomic, so it ends up being I2, and iodine is a solid. Now this one's another one that's sweet. If you look, we've got 1 barium, 2 iodine, 2 chlorine, so that one is already balanced. All right. Number 6, we have aluminum plus iron nitrate. So we're going to compare aluminum and iron. Aluminum is up here. Iron is down here, so aluminum is more reactive. Aluminum gets the star, which means aluminum is going to take, oops, sorry, I'm on the wrong one. Aluminum is going to take iron's place, so we're going to end up with aluminum nitrate plus iron ends up alone. So iron is just iron, okay? So since the reaction happens, we're going to write the equation. So we start out with aluminum solid plus iron. That 3 tells me it's got a +3 charge. So iron's +3, nitrate is -1. So FeNO3, 3. All right, aqueous. Plus aluminum nitrate. So aluminum's +3, nitrate's -1. So AlNO3, 3. Aqueous. Plus iron, Fe, solid. All right. Wow, I did a really good job of giving you a bunch of balanced ones. That one's balanced too. Okay, moving right along. Number 7, copper chloride plus aluminum. So copper is all the way down here towards the bottom, and aluminum is up here. So aluminum is higher up. So aluminum gets the star. Aluminum wants to be in the compound, so aluminum is going to kick copper to the curb. We're going to end up with aluminum chloride plus copper. All right, so we need to write some equations. Copper 2, so copper has a +2 charge. Chlorine is a -1. So this is CuCl2, aqueous, plus aluminum. We're actually going to do a lab that is this equation. So solid aluminum. Going to produce aluminum chloride. Aluminum's +3, chlorine's -1. So AlCl3, aqueous, plus copper, solid. This one is not balanced. If you notice here on the left, we have 2 chlorine. On the right, we have 3. So the least common multiple of 2 and 3 is 6. So if I put a 3 here, it gives me 6 chlorine. If I put a 2 here, it gives me 6 chlorine. All right. And I have 3 copper, so I need 3 copper and 2 aluminum. All right. Magnesium plus hydrochloric acid. Now, I gave you the formula for hydrochloric acid because it's kind of interesting. Hydrogen, there go the puppies again. Interestingly enough, hydrogen is on the list of metals, even though we know it's not a metal. Okay, hydrogen is on the list because if you think about its position on the periodic table, it's in group 1 with all of those metals. Okay, so when we see hydrogen, we're going to compare it with the metals. So we are going to compare magnesium and hydrogen. All right, so if I've got hydrogen here, oh my gosh. Boys, shh. Okay, that lasted. Sorry, guys. Puppy problems. Hydrogen, magnesium. Magnesium's way higher than hydrogen. So magnesium is going to take hydrogen's place. And I should have probably written this as hydrogen chloride. Okay, so magnesium takes hydrogen's place. So we end up with magnesium chloride plus hydrogen. Okay, so we have magnesium, Mg, which is a solid. I give you the formula for hydrochloric acid. It's HCl. It's going to be aqueous. Those two react to give me magnesium chloride. Magnesium's +2, chlorine's -1. So MgCl2 plus hydrogen, which is a Haber-Finkel. It's a diatomic element, meaning it's H2, and it's a gas. All right, so this one's nice. You just put a 2 here and it's balanced. All right, zinc chloride and iodine. Remember, iodine is on this short list down here. Iodine is all the way at the bottom, which means whatever this is, chlorine is higher than iodine. So chlorine is the one that wants to end up in the compound, which means, since chlorine's already there, this is a no reaction. All right, one more. We have magnesium chloride and sodium. So magnesium is here. Sodium is higher. So sodium gets the star. Sodium is the element that's going to end up in the reaction. So we are going to have sodium chloride plus magnesium. Okay. So magnesium's +2, chloride is -1, so we end up with MgCl2, aqueous, plus sodium, which is a solid. Those react to give us sodium chloride, so sodium's +1, chlorine is -1, so NaCl plus magnesium, so Mg. Let's see, this one, we've got 2 chlorine, so we need a 2 here, and then a 2 here, and our equation is balanced. All right, guys, so a quick rundown of today's homework, single replacement reactions. I hope that video helped. I hope this is making sense, and I will see you in class. Take care.